right, let's go over the worksheet from Friday. So starting with the 8.1 side. Number 1, first you check to see if they multiply together. So we take x times y, so 2 times 10 equals 20. We have 4 times 5 equals 20. We have 5 times 4 equals 20. And we have 20 times 1 equals 20. So this is an inverse variation. And our equation is y equals k over x, or in this case, 20 over x. Number 2, first we start by multiplying x times y. So we have 1 times 2 equals 2. And 3 times 8 equals 24. So this is not an inverse. So then we start by dividing y divided by x. So we take 2 divided by 1, which equals 2, and 8 divided by 3, which equals 2.6, repeating. These are not equal, so this is not direct. So for number 2, this would be neither. Number 3, we take 1 times 6 equals 6. And then 2 times 12 equals 24. This is not inverse. Then we divide. 6 divided by 1 equals 6. 12 divided by 2 equals 6. 30 divided by 5 equals 6. And 42 divided by 7 equals 6. Since these all match, this is a direct variation. And our equation is y equals 6x. Number 4 follows the exact same pattern. When we check to see if they multiply together, they do not. But when you take y and divide by x, they do. So this is a direct variation. And we get y equals 125x. Number 5, we had to first write our inverse variation by multiplying x equals 7 and y equals 2 together. So that's the first step. We get k equals 14. So we have y equals 14 over x. Next we sketch a graph. We have asymptotes of the x and y axis. It's in the first and third quadrants. And now we plug in 10. So we have y equals 14 over 10, or 7 over 5. Number 6, you should have y equals 0.8 over x. Graphing that is in the first and third quadrants. And again, when we plug in 10, we get y equals 0.8 over 10, which equals 0.08. Number 7, we get y equals 0.3 over x. When we graph it, is in the first and third quadrants. And when we plug in 10, we get y equals 0.3 over 10, or 0.03. Number 10 is the story problem, or the real-life situation problem. First of all, we have to model that data. If you multiply 5 times 72, you get 360. If you multiply 6 times 60, you get 360. If you multiply 8 times 45, you get 360. If you multiply 9 times 40, you get 360. So this is an inverse variation. Our equation is y equals 360 over x. So then for part B, it wants to know how many hats if we charge 750. So we just plug 750 in for x. So we have 360 divided by 7.50, which is going to equal 48 hats. For number 11, we just multiply the numbers together. That was supposed to have a comma in between. So 3 times 1/3 is 1. or k equals 1. Number 12, k equals 1.2. And number 13, k equals 50. For number 14, it says z varies jointly with x and y. So we have z equals k. Jointly means we're going to multiply by x and y. So first we start by plugging in 7, 2, and 28. So we have 28 equals k times 7 times 2, or 28 equals 14k. So k equals 2. Now we plug that back in. We have z equals 2xy. And now we go to the directions where it says find z when x equals 6 and y equals 4. Z equals 2 times 6 times 4, or z equals 48. Number 15, we have z varies directly with x and inversely with the cube of y. All right, so first thing I have to do is take that data and find k. So x equals 8, y equals 2, and z equals 3. So we have 3 equals k times 8 over 2 to the third. 2 to the third is 8. These actually cancel, and we find out that k equals 3. So we have z equals 3x over y to the third. Now again, we're going to plug in 6 for x and 4 for y. So z equals 3 times 6 over 4 to the third. Or in this case, 9 over 32. All right, let's move on to the 8-2 side. In number 1 and number 2. First of all, identifying the x and y intercepts. There are no x and y intercepts. State the asymptotes. We have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0. And then state the domain and range. The domain is negative infinity to 0, 0 to infinity. The range is negative infinity to 0, 0 to infinity. Again, remember, domain is the x values and range is the y's. Now, the only difference in the graphs between the two, for number 1, the graph is in the first and third quadrants. And for number 2, because the a value is negative, it is in the second and fourth. For number 3 and 4, they just want to know what the a value is going to do. So for number 3, if I have y equals 3 over x, this is a stretch. For number 4, if I have y equals 0.4 over x, this is compressed. Because remember, that number is between 0 and 1. For number 5, we are sketching. And of course, identifying the domain and range. So here, we sketch the asymptotes. When I have y equals 1 over x plus 3, I have a vertical asymptote at 0, x equals 0, and I have a horizontal asymptote at y equals 3. 0 is what makes this denominator 0, and 3 is, of course, what's added to the end. So I have a vertical asymptote right on the y-axis. I have a horizontal asymptote at positive 3. My graph is going to be in our first and third quadrants. And of course, my domain leaves out where my asymptote is. So it goes negative infinity to 0, 0 to infinity. My range course, leaves out where my horizontal asymptote is. Negative infinity to 3, 3 to infinity. All right, let's do number 6. Number 6, we have y equals 3 over x plus 1, and then plus 2 after it. This means it moves to the left, or we have a vertical asymptote at x equals negative 1. We have a horizontal asymptote at y equals, this went up 2 or positive 2. So again, if I graph this, I have a vertical asymptote at negative 1. I have a horizontal asymptote at positive 2. Since my a value is positive, this is in the first and third quadrants. My domain, the only place it cannot exist is where my vertical asymptote is. So that's negative infinity to negative 1, negative 1 to infinity. My range cannot exist where my horizontal asymptote is. Negative infinity to 2, 2 to infinity. And the last two problems today, you're writing the equation. For number 7, if we have the parent function y equals negative 3 over x, and we are going to have a vertical asymptote at negative 1 and a horizontal asymptote at 3, it changes this equation into y equals negative 3 over x plus 1, because again, you have to add it over, and plus 3 at the end. For number 8, if we have y equals negative 3 over x, again we have x equals 0 and y equals 6. That means I have a vertical asymptote at 0. Does that move this right or left? It does not. So I have y equals negative 3 over x. But this moves it up 6. So I have plus